So looking at yesterday's worksheet, let's start by looking at this one we did yesterday. We filled in the table with the little slope field pieces. We graphed all the pieces. We said, that sure looks like a circle. Now let's figure out for sure what it is. So we're going to start with dy dx equals negative x over y. And I can't really differentiate, or underivative that, because I don't know how to take an antiderivative of x over y. So to solve this differential equation, the method we're going to use today, so here's the title of today's lesson over here in the margins, differential equations. Right, small differential equations solved by separation of variables. Differential equations, so an equation with a derivative in it, and we're going to solve it by separating the variables. Now, let me step back and talk big picture for a minute. Differential equations is the name of an entire college math course that comes after Cal 3. So if you guys are headed toward math major or engineering, Cal 1, Cal 2, Cal 3, differential equations, and then partial differential equations. So needless to say, we're just going to be scratching the surface of differential equations. There's a ton of them, a ton of ways to do them. We're going to do the simplest ones with the simplest method. I mean, that's not to say this is easy. It's just to say that relative to all the other differential equations, which you might learn about your junior year of a mathy, sciencey major, these are easy. But again, that's relative. Separation of variables. Well, the name tells you what to do. Let's separate the variables. So let's get all our y stuff on one side and all our x stuff on the other side. So I'm going to multiply both sides by y. And this is a little bit weird because dy dx we normally think of as like one term, it's the slope. But in certain instances we can kind of break it apart, multiply both sides by dx, and put the dx on the other side. We've separated the variables.
So you really just cross multiply.
Yep, you could phrase it that way. Cross multiplied. Got x's on one side, y's on the other. Now we're going to take the antiderivative of both sides. Notice I put it on there where the negative was out front, so I didn't really have to worry about it. That kind of thing happens a lot today because you can do that with a constant. You can put the 4 or the 7 or the 1/2 out front. Let's do the right-hand side first because I think it's a little easier because we're more familiar with x's. So what's the antiderivative of x?
X squared over 2.
X squared over 2. And that negative is still there. Plus c. What about on the left side, the antiderivative of y with respect to y? Yeah, so it's the same thing. It's just a different letter, but it's the same thing. Y squared over 2. Oh, good point about the plus c. I can put a plus c on there if I want to, but since there's already a plus c on the other side, I don't need to. So you can put it on either side or both. Nobody puts it on both. And most people put it on the x side because we're usually solving for y, and so you might as well start with it in the right spot. Let's see, fractions look a little bit weird, so let's multiply through by 2. Y squared equals negative x squared plus, now this is going to be a little bit odd because c can be any number right now. I haven't assigned it a value. I don't know what it is. In fact, it's not really anything. There's nothing to tell me what it is. It can be any constant I want. So if I take any constant I want and multiply by 2, I could put 2c, but I still just have any constant I want because I haven't assigned it a value yet. If you want to put 2c, that's fine, but most people are going to leave off the 2 just because it's still just c. if that bugs you, you can put 2c, or you could put a subscript on there to kind of indicate that, hey, I know those aren't exactly the same c, but they kind of are the same because it doesn't matter what it is. Let's move the x squared to the left. So x squared plus y squared equals c. And hopefully you remember enough conic sections to think, oh yeah, that's a circle. This is a fairly frequent AP type question where they give you a differential equation. They ask you to do some slope field stuff with it. Then they ask you to solve it sort of analytically. And hopefully you make the connection of, oh yeah, that's a circle, so I must have done both of those right because they kind of match up. And then they can ask another question or two after that. Most students like those because they feel pretty good about sketching slope fields and doing antiderivatives. So we didn't really do any notes today. Like that's the notes, is take the antiderivative, or separate the variables, and then take the antiderivative of both sides. Well, let's do a couple more examples together, mostly to handle the algebra. Solving differential equations. By separation of variables. Again, we already did one. We're just going to do two more for examples, and then we'll do one together off of the notes and see how you, or off the homework, get you started on it.
We're going to have to draw a slope field.
Yes, on the test you will have to draw a slope field.
But right now.
But not for now. So these are two separate things, but they're very much related to each other. Like, we could have you draw that slope field, but today, instead of drawing the slope field for that, we want to solve for y. So it's good to think big picture. Slope fields helps you graphically see what this solution would look like, because they're easy to do. You just plug in a whole bunch of points and sketch the little slope pieces, and you get a picture of what your solution would look like. Today we're going to do it a little more analytically and get a more precise equation that is the solution to this differential equation. So they're usually separate, but we can come up with some questions where we ask you to do both. And there is one or two on Friday's test that does both. So it gives you this, asks you to draw the slope field, and then asks you to solve it. And if you know the graph and the equation well, you can see that they match. So it provides a bit of a check on itself. All right, solve for y. Y prime is fine, but when we're doing separation of variables, it's probably better to write it as dy dx. Because then we can separate the variables. Y prime has dy and dx sort of embedded in it, so you can't separate them. All right. Well, here's where describing it as cross multiplying may not work so well, because we're going to divide both sides by 1 plus y. Multiply dx over. So now we've got all our y's on one side and all our x's on one side. And we can integrate. Right hand side's easy. How about the left hand side though? We can do u sub and not tangent. Tangent would be 1 plus y squared. Let's do u sub and see what happens. So if I let u be the, well, what do you want to let u be? 1 plus y. Du then is just dy. So the integral of du over u. that's the natural log of u. So the natural log of the absolute value of 1 plus y equals x squared over 2 plus c. Well, calculus is easy, algebra is hard. We're done with the calculus for this problem, but we still want to solve for y, so I've got some algebra steps ahead of me here. How could I undo a natural log, or what could I do to rewrite that equation? What is the inverse of natural log? E. So I'm going to go e to both sides, or I can do the fishhook thing. But either way, I get e to the x squared over 2 plus c equals 1 plus y. So if I solve for y, I get e to the x squared over 2 plus c minus 1. Be careful and be neat when you're writing these down so you don't end up with minus 1 in the exponent or c not in the exponent. So make sure it's clear who's where. Perfectly acceptable safe stop, except that that's not what the multiple choice answer is going to be. As always. What do you mean bring down front? You're right.
Can you bring down the variable that's having a natural log?
Not within. I mean, yeah. If you natural log both sides, then this thing would come down front, but then you'd end up with kind of where we started with. What makes exponents add? Let's back up and think back to our Algebra 1 days. Multiplication? Yes, multiplication. Like if we have x squared times x cubed, that's x to the 5th. We added the exponents. So with this exponent that's been added, I kind of want to unadd them and write it as this way. So e to the x squared over 2 times e to the c minus 1. It's like, well, why in the world would you do that? Like, that doesn't really help things. Except that e to the c, so c is any constant right now. C is any constant we want it to be. Well, that means e to the c is just any constant we want it to be. So I'm going to call it capital C just because it looks better now. C e to the x squared over 2. So a little bit of algebra gymnastics there to make that happen. So separate the variables, integrate both sides, and then do whatever algebra you need to. By the way, this is called a general solution because we don't know the particulars. We don't know C. Don't know what C looks like. So I can't get any more specific than that. I can't get any more particular than that. Questions on that one? Separate the variables, integrate both sides, algebra. Let's do another one. Y prime equals 3y plus 6. Y of 0 equals 7. And the directions for this would be something like find the particular solution. So like use y of 0 equals 7 to find C, to know exactly what the answer is. So it adds a step on at the very end. Let's see, dy dx equals, I think to help separate these, I'm going to factor out a 3. Don't have to do that, but it makes life a little easier later. dy over y plus 2 equals 3dx.
Now, why do you have to do that? Why can't you just take an integral?
Why can't I take an integral like right here?
Yeah.
Because if I try to just integrate that, well, for one, it's the integral of y with respect to x, so that's going to be, that's why I got to separate the variables to get the y's with the y's. So that's not really wrong, it's just I can't do that. At least not in this class we can't do that. So that's why we separate the variables. It's a good question, and in fact, on the AP test, when they give these questions for free response questions are all worth 9 points each. This piece of it would probably be 3 or 4, and you'd probably get 2 points. You always get at least 1, you may even get 2, for making it just to that separation of variables phase. So like even before you integrate, if you separate the variables, you're going to get some credit for that particular problem. Integrate both sides. Oh, this 3, you could have put 1/3 on the other side, be equally accurate, but why mess with a third when you could have a 3? You get to pick. You want the 3 in the numerator or the denominator. Most people are going to pick the numerator. So it's your choice. You can do some algebra ahead of time to sort of rig the integrals to be a little bit more in your favor. Left side's easy. I don't know where the 2 came from. 3x plus c. How about on the left? You can do u sub. You know what it's going to be without having to write out the u substitution? Yeah, it's du over u, so it's going to be natural log. So if you're to the point where you can see that, that's fine. You don't have to write out u substitution you've done it in your head basically. You recognize u is the bottom, du is the top, so it's natural log. That's okay. If that's too many steps in your head, well then take the time to write it out. There's nothing wrong with that. All right, I think our calculus is now done. Now I need to rearrange and solve for c. Solving for c can be done anywhere along the process. It's just dangerous because when you start messing with c, you better know which c you're solving for, especially if you've multiplied by 2 or divided by 3 and you've sort of changed it a little bit. My preference is to do the algebra first and then figure out what c is. Some people like to solve for c like right away, like let's plug in 0 for x and 7 for y and see what we get. And you can do it that way, but then you still have to do algebra to get y by itself. I'm going to do the algebra first and then solve for c. So e to the 3x plus c equals y plus 2. So y equals e to the 3x plus c minus 2. Oops, that's a c. Now we're going to do this little algebra trick with exponents. We do this quite often, so I hope you're used to it. I hope you're okay with it. Sort of unadding the exponents. Then I realized that e to the c is just a constant. So y equals c e to the 3x minus 2. This is where we stopped last time. In fact, this is the general solution. It's not really what we want for this problem. But it is the general solution because I haven't found c yet. So let's use 0, 7. 7 goes in for y. 0 goes in for x. 7 equals, e to the 0 is 1. So c equals 9. Let's go go back to here. Don't go all the way back up to the top. Go back to where you found y. Y equals 9 e to the 3x minus 2. If you were so inclined, you could take a derivative of that and see if you got back to 3y plus 6. Most people aren't going to do that. What I would suggest is that you check now to make sure 0, 7 works at least. So 7 equals 9 minus 2. Yes. You don't have to check, but that's a real easy check to make sure your that initial condition they gave you works. Oops. And that would be the particular solution. The specific solution, the exact solution, we know what C is solution. All right, if you're watching at home, grab the worksheet that I posted because we're going to do number 6 together. All right, so there's number 6 from the worksheet. Press pause, try it at home, give it a go, and then we'll go over it. I guess a hint, though, would be, it's not the hint, it's the method. Separate the variables. Might need a u substitution. Careful with the power rule and the square roots. So give it a try, and then we'll go over it. All right, so there's your separation of variables point or 2 to get all the y stuff together and all the x stuff together. Power rule over here on the left. Over here on the right, u substitution, because if you pick the right u, du shows up. So give that a try, and then we'll go over some more of it. So power rule on the left, up the power by 1, divide by the new power. On the right is one of those you just have to recognize that if I let u be natural log, then du shows up because it's 1 over x dx, and it turns into an easy integration as long as you pick the u correctly. U squared over 2, plug u back in, and now we're done with calculus. Now we're on to algebra. I need to solve that for y, and eventually plug in the point e comma 9 to figure out what c is. So I'll pause here and see if you can go from there.
C squared.
So I divide by 2, make that go away. These are now different c's, but it doesn't really matter because I haven't figured out what c is yet. 1/2 is a square root, so I'm going to square both sides. I can't square the pieces, though. I have to square the entire right-hand side. So I'm kind of just stuck with natural log of x squared plus c squared.
Do you have to do that? Because if you square the c, it's still the c.
It would be, but I can't get the square to the c without also like foiling that thing. So I think I want to just leave it alone. The question was, isn't c squared just c? And yes, it is. If I foiled this out, then when I got c squared, I could leave it as c, but I don't want to do that. Lastly, let's do some algebra. Y is 9. E goes in for x. Calculus is easy, algebra is hard. What's the natural log of e? Calculus, 1. 1 squared is 1. And maybe you square root both sides, but maybe you just look at that and figure out what c should be in order for it to work. Either way, square root both sides. So c is 2. Now, be careful when we plug it back in. We messed around with c a little bit, so we better pick the right spot to plug c back in. I think it was when we solved for y, that's the c that we want. So y equals natural log of x squared plus 2 squared. There's our particular solution. As opposed to our general solution. So when they give you a point, they can ask you to get the exact solution. If they don't give you an initial condition, a point to work with, then you would just be stuck here with C. And there's at least one of each on the test. So if there's no information to start with, then you get it to a C, and that's as far as you can go. If they give you information, then you can get to the point where you can solve for C. All right, on the worksheet I gave you, let's do 1 through 11 odd. And then 12 through 16 are a little bit easier, so we'll do all on those. So on the first 11, a lot of those are repetitive, a lot of similar problems in there. So just 1 through 11 odd, and then 12 through 16 all.
So that's all we have to do?
Correct. We did 6. Yeah, I was waiting for somebody to complain that the one we did was not really one that's assigned. Let's do a couple of hints here, because some of these look a little bit weird. Like number 11, f prime of x equals 2 f of x, and f of 2 equals 1, so 2, 1 is the point we're working with. F prime equals 2 times f. How can I, what's another way to say f prime? dy dx. So it doesn't look good right now. Like I can't separate, I don't know what to do with this. But if I replace f prime with dy dx, what do I need to do with f of x then? It's not the same thing as y. So now that's a lot easier problem to work with. We didn't really change anything except the names, the symbols, because now we can separate variables and go from there. In fact, may as well finish this one while we're here, because that one's not too crazy. Natural log of y equals 2x plus c. So e to the 2x plus c equals y. I can do my algebra tricks here. E to the 2x, e to the c, which just means c, e to the 2x. And so that's my general solution. I'll use 2, 1 to get the particular solution. Oh, now I'm remembering why I wanted to work this one, in addition to looking weird to start with. So c equals 1 over e to the 4th. That's kind of weird. So there's a safe stop answer. But I bet a multiple choice test doesn't look like that. I have e to the 2x over e to the 4. What can I do with the exponents? Subtract them and get e to the 2x minus 4. Which means maybe I should have found c right here, and I would have saved myself some steps, but I didn't really know that at the time. So that's why people argue about, well, should you find c right away or do you wait till the end? And it kind of depends on the problem, but you don't know which one is the choice until you pick a path and see if it works or not. Either way, you're going to end up with the same thing. But if we had started right here solving for c, it might have gone a little bit quicker. But that's only for this particular one. The other ones, it worked better the way we did them. So look at number 14, because I don't know if we've done this or not. Just looking at words, making sure we can interpret what is being said. Interpreting English into math. rate of change of n with respect to s, you've already got this written down, so is proportional to 250 minus n. I just wanted to write it down because I can color code some things now. Rate of change of n with respect to s. That's a lot of words. Can you simplify that into some calculus symbols for me? Yeah, dn ds. So all that just means is dn ds. Is proportional to. Remember how to do proportionality stuff? Equals is part of it, but it doesn't just say it equals 250 minus n. It's proportional to 250 minus n. In fact, I guess we could have said the is was the equal part, and proportional means there's a k there. Running out of colors. There we go. Red, green, blue, orange. And I think it says write and solve the differential equation. So we wrote the differential equation. Next we would solve it. So now it's just like 1 through 11. 15 and 16 are similar. So just translating. Although 15 says inversely proportional. Inversely proportional would mean equals k over whatever it's inversely proportional to. It's number 15. And it's kind of weird. 14 looks like it'd be a simpler problem because 15's got a square root and a denominator. But once you separate the variables, you realize that 15 is probably the easier question. Because you're going to have r to the 1/2 dr and k dt. So no exponents, no natural logs, none of that stuff for number 15. So it looked bad, but it turned out nice. 14 looks nice, and it's going to turn out ugly because you're going to end up with a natural log. All right, again, try them. Check answers online. Check answers, like the PDF of the answers is available, as well as the video of me walking through the ones and explaining them.
What does varies jointly mean?
It means both.
What?
Varies jointly. So that would mean equals k times x and L minus y. So it means varies both with x and L minus y.